Welcome to this new activity, which is about integration by parts. So here we're gonna try to find the integrals by using integration by parts. First of all, let me make a reminder on the integration by parts rule. So if you have two functions u and v, and you have the integral of u prime v, then it's equal to u times v minus the integral of u v prime. The most difficult thing when applying the integration by parts is the choice of u prime and v. And here I will give you a hint before starting our activity. So if you have an integral of a polynomial times a logarithmic function, then you consider u prime as the polynomial and v as the logarithmic function. Now, if you have the integral of a polynomial function times an exponential function, then you consider u prime as the exponential function and v as the polynomial function. Okay? Now, let's try with the first one. The integral of x ln of x. Here we have a polynomial of degree 1 and a logarithmic function. So we're going to consider u prime as x and v as ln of x. Now, if u prime is x, then by integrating this, you will get u equals x squared over 2. And if v is ln of x, you differentiate. It means you compute the derivative, and v prime is 1 over x. Now you apply the rule. So the integral of x ln of x, which is u prime v, is equal to u times v. It means x squared over 2 times ln of x. So it's equal to x squared over 2 ln of x minus the integral of u times v prime, and x squared over 2 times 1 over x. You can cancel the x. It means simplify by x. You will get x over 2 dx. And here it gives x squared over 2 ln of x minus, you can put the 1/2 outside, and the integral of x is x squared over 2. So you will get at the end x squared over 4. And don't forget plus c. Next one, we have a polynomial x squared times an exponential. So following my rule, I will choose u prime as exponential x, the exponential, and v as the polynomial. The idea is to get rid of this polynomial and compute the integral of the exponential. So u prime is exponential x, u is exponential x. The integral of exponential x is exponential x, and the derivative of x squared is v prime equals 2x. We didn't get rid totally of this polynomial, but you will see that we need a second integration by parts. So let's first apply the integration by parts rule to this integral. So the integral of x squared exponential x dx equals u times v. It means x squared exponential x minus the integral of u times v prime. It means 2x exponential x dx. And as you can see, we can't use the integration by substitution to get this integral. So we need a second integration by parts to compute this integral, this new integral. So we will forget about the 2. We will put it in front of this integral and compute just the integral of x exponential x, and then substitute the integral here by the result. Okay, so let's take it separately. The integral of x exponential x dx. Again, here we're gonna use the integration by parts. So we'll forget about what's before, and we're gonna take u prime again equals exponential x, and v equals x. U prime is the exponential, v is the polynomial. So we'll get u equals exponential x, and v prime equals 1. And here you obtain a constant, and when you obtain the constant, you are sure that you are done with your integral. So let's apply the integration by parts. Equals u times v, which is x exponential x, minus the integral of u times v prime, and 1 times exponential x is exponential x. And now you are able to compute this integral, which is exponential x plus c. Okay, now we're going to substitute the integral of 2x exponential x by its expression. Okay, don't forget that we have x squared exponential x at the beginning, so the final result will be the integral of x squared exponential x dx is equal to x squared exponential x minus, don't forget the 2, and now you substitute your integral by the obtained expression here, which is x exponential x minus exponential x, and you can put the plus c outside of everything at the very end of your expression, since 2 times a constant is also a constant. Okay, so of course we can write it better than this, so we're gonna put the exponential as a factor, so you will get x squared minus 2x plus 2 times exponential x plus c, and this is the final result. This is also considered as a correct result. Okay, next one, the integral of ln of x over x squared. Here we can't directly apply the integration by parts since we don't see a product of two functions. So first of all, let's write it as a product of two functions by using negative powers. So we're going to write it x to the power of minus 2 ln of x dx, and I will choose u prime equals x to the power of minus 2, the polynomial, and v, the logarithmic function ln of x. So if u prime is x to the power of minus 2, u is x to the power of minus 1 over minus 1, or simply minus 1 over x. And if v is ln of x, v prime, its derivative is 1 over x. We apply the integration by parts rule. So the integral of ln of x over x squared dx is equal u times v, it means minus 1 over x times ln of x, which is minus ln of x over x, minus the integral of u prime, u times v prime. It means minus 1 over x times 1 over x, which is minus 1 over x squared. With this minus sign, you can write plus 1 over x squared dx. And you can use the negative powers to get this integral. So let's rewrite it. So minus ln of x over x plus the integral of x to the power of minus 2 dx. And again here, use the power rule. So you will get minus ln of x over x plus x to the power of minus 1 over minus 1, or simply minus 1 over x, and don't forget plus c. So the final result is minus ln of x over x minus 1 over x plus c. Last one, the integral of 4x exponential to x. So here we have a polynomial times exponential, so I will use u prime as exponential and v as the polynomial for x. Here, if u prime is exponential to x, u is 1 over 2 exponential to x. Remember that the integral of exponential ax dx is 1 over a exponential ax, of course, if a is not equal to 0. So u is 1/2 exponential to x, and if v is 4x, v prime is 4. Now, we're going to use the integration by parts formula. So 4x exponential to x, the integral of 4x exponential to x dx, there is missing the x here, okay, is equal u times v, which is 1 over 2 exponential to x, times 4x, which is 2x exponential to x, minus the integral of u times v prime. It means half exponential to x times 4, which is 2 exponential to x dx, and it gives 2x exponential to x minus exponential to x, because you will have 1/2 times 2, which is 1 exponential to x plus c. We are done with this integration by parts activity. Thank you for your attention and see you in the next videos.